Ooh, it's spooky. Oh, wrong side. You see my bats? My bats right there. They're like floating in midair. It's a magic trick. Don't think too much about it. Hey, welcome to lesson 3.3, Analyzing Variation and Reproduction. Let's first go to our warm-up like we always do. We're going to look at a picture from the article, Identical Twins, and answer this question. Let's go ahead and jump there in Amplify. Activity 1. Almost. Really wants to. Let's hide that. Here we go. Students use a diagram from the Why Are Identical Twins Rare article to explain why offspring have 2 copies of each gene. Here's our diagram. You have a reproductive cell from the mother, the egg cell, the reproductive cell from the father, the sperm cell, and you have the offspring cell right here. Use the diagram to explain how the offspring receives 2 copies of each gene. Refer to the word bank above when writing your response. Remember, the whole point of sexual reproduction is that offspring receive genetic material from each parent, right? So answer this question and come on back to me. Next, we're going to be jumping into the sim, and we're really going to be trying to apply some of what we're learning about inheritance and sexual reproduction and the passing on of genes from parents to offspring. So we're really going to be testing what we understand because we're going to be making some predictions as it says. So put your thinking caps on. Here we go. Here's our investigation question. How does sexual reproduction result in variation among offspring? Because remember, from the very beginning, let's go to the next slide. I think that's going to say it. We were looking at this spider family tree, right? And even though these baby spiders have the same parents, there's variation among the offspring, isn't there? Some of them have the same trait as one of their parents. Some of them have a completely different trait. Like offspring D has the high silk flexibility trait, where neither parent has that. So we'll look at why spider offspring have different traits for silk flexibility, even though they have the same parents. So here's what we're going to do. We're going to be jumping in the sim, like I said. We will mate spiders in the sim. I think it's Anne and Greg. We'll see. And we're going to predict the gene versions the spider offspring will have. Yes, we are predicting gene versions. Not just traits, but actually the gene versions. And then we're going to actually use the sim to see if we're right. Greg and Anne. There you go. So we'll look at this example together, Greg and Anne. And we're going to look at silk stickiness. So I had the simulation up. Here we go. Silk stickiness. I want to click on that. And Greg, there's Greg. Trait sticky, S1, S2. There's Anne, also sticky, S1, S2. Great, fantastic. So what we're going to do, it says, hey, I'll record your predictions and tests in this data table. I'm not doing that. I'm just going to do the same thing that you're doing. In number 2, activity 2. Are you ready? So you can do the same exact thing as me. Greg's gene versions for silk stickiness. What was it? S1, S2? S1, S2? Is that right? I just want to double check. Was it S1, S2? It was S1, S2, and his trait was sticky. Sticker. And Anne's was the same. S1, S2, trait, sticker. Okay. So we want to make predictions. And this is where you are going to make some predictions. So, which gene version? Now, you're only going to put in S1 or S2 in this, right? Because that was Greg's gene version was S1, S2. But which one is Greg going to give to this offspring, right? So let's say we think, okay, Greg's going to give S1, okay? I think Anne is going to give also S1. And what would the offspring's gene version be? You guessed it, S1, S1. Oh, cool. What about offspring B? Is there another combination? Sure. What if Greg gives S1, but Anne gives S2? What would that offspring be? S1, S2. See what we're doing here? What if Greg gives S2? And Anne gives S1. That would be S2, S1, which is also the same as S1, S2, right? Same thing. What if though Greg gives S2 and Anne gives S2? We'll have an S2, S2, won't we? Any other combinations that we can think of? I don't know. So you're going to hit save and continue. I mean, just do the exact same thing I did right there for number 2. Hit save and continue. And then what are we going to do? We're actually going to check it out. Let's try it out. So select silk stickiness. I already did that, remember? And we're going to observe Greg's and Anne's traits for the gene versions. What traits in gene versions do Greg and Anne have? We said that they both had sticky, right? Right. Let's go to the thing. Greg, sticky, Anne, sticky. Okay, they both have sticky silk. And then record Greg and Anne's. Oh, we already did all that. We did all that. We made our predictions, right? And now I'll record your prediction. We already did that. Now let's test it. Thank you. We'll finally get to slide 17. And let's observe their offspring. So I'm going to go ahead and do that. Let's do that right now. Greg and Anne going to make spider babies. Let's create our reproductive cells. Oh, not that. Oh, here we go. And let's randomly fertilize. Doobity-doo. Nature. What did we end up with? What are our offspring? What is the question that we're supposed to answer here? Oh, record the results. I'm not going to record the results. You can see the results right there. We'll go right back to them. But here's the question: how do the results compare to your predictions? Did we predict an S1, S1? I believe we did. Did we predict an S1, S2? Or S1, another S1, S1? We predicted S1, S1. Okay, that was one of our predictions. What about S1, S2? Did we predict that? Oh yeah, there it is right there. And what else we get? S2, S2, S1. Remember, it was the same thing. We got one of those too. We didn't get one of these. Does that mean we were wrong? I don't know. Well, we should do it again, shouldn't we? Now you're going to do this on your own. I'm going to let you do this. So you're going to do this with Otis and Ruby, and you're going to do body color instead, but follow the same exact format. But now, when you go to number 2, it actually has a place for you to record the results. That's the only difference between the previous one and this one. Now you can record your results, not once, but twice. Do it twice and see what the gene combinations are and what the traits are, okay? And then wait, are you only going to do that with... Hang on, give me 1 second. Here's where I want to be. I thought they were going to have you do another pair of spiders and another trait, but no, I'm sorry, or another feature. Here's the big question. How did sexual reproduction lead to variation in body color in Otis and Ruby's offspring? Because sexual reproduction led to... It's the inheritance of the genes, right? So we received any variation in copies of genes from each parent. So how does that result in the variation of body color, which is the trait, right, of the offspring? Did the resulting offspring have the same gene combinations each time the 2 spiders mated? Did they have the same? Let's move to this. How do our tests in the sim help us answer the investigation question? How does sexual reproduction result in variation among offspring? The sexual reproduction, the passing on of the genes, one from the dad, one from the mom. How does that result in variation among the offspring? Do you always know which gene dad's going to pass on? Do you always know which gene version mom's going to pass on? Seems like maybe not. Next thing we're going to do, modeling Venom inheritance. Now, again, I have taken the modeling tool, I've uploaded it to Google Drawings, and it is attached to your lesson, so that makes life so easy for you, right? So easy. Mr. Reagan, my life's not easy. Okay, fair enough. So now that we have investigated how sexual reproduction can lead to variation, we will use the modeling tool to look at a new feature, Venom, and apply what we've learned. So here's our modeling tool. Here's what it's going to look like. You're going to fill in this part right here. Now we see the gene versions of mom, the gene versions of dad, and we have the offspring right here. What you're going to do is you're going to predict, well, what do you think? What are the possible gene versions of the offspring? Given moms and dads gene versions, what could we end up with? What are the possible combinations? Oh, and look, it shows us proteins too. Should we draw these proteins also in the cells? Yeah, why not? Sounds great. Which proteins go to which genes? I don't know. Look in the sim. Oh, there you go. Look in the sim. Open up the sim and see if you can find out. Click on Venom and see what types of proteins are made in the cells. See which spiders have a V1, V2 gene combination, and find out what those proteins are. So in activity 3, here it is. Here's the goal. Use Venom as an example. Show how the gene versions of siblings can be different from each other and from their parents. Create a model using that modeling tool that I uploaded for you that shows how the offspring could have different combinations of gene versions. Also, draw and label the proteins each spider likely has in their cells. Add annotations. Add some annotations for them, please, to explain how each spider offspring received those gene versions and proteins, okay? Tips. Try to use the following science words in your annotations: proteins, traits, gene versions, heterozygous, homozygous, and sexual reproduction. If you are getting really comfortable using these terms, that's going to help you so much for the upcoming tests. Optional, you can use the sim. I have already suggested use the sim. It'll help you out, okay? Definitely for that. And we're coming up to the end here. Remember, we're investigating variation within this spider family. That's where we all started, right? Where all of this started. Why is there so much variation? The siblings are different from one another. Some of them are even different from the parents. The spider offspring have different traits from each other, and some even have different traits from their parents. Remember, we already said claim 2. We don't agree with claim 2. We were refuting claim 2 that one individual might have the same trait as a parent because it received more genes from that parent. We said, no, that's not the case. They receive the same amount of genes from each parent, right? So does the evidence that you gathered today support or refute claim 1 or claim 3? Well, there it is. Giving it away. Key concept number 12. Through sexual reproduction, each offspring can inherit a different combination of genes. Therefore, siblings can have different traits from each other and even from their parents. That's answering our question right there. Through sexual reproduction, each offspring can inherit a different combination of gene versions. Therefore, siblings can have different traits from each other and even from their parents. That's the whole goal of sexual reproduction, to create variation among offspring, which is very good for the survival of a species. So we would say that we are supporting claim 3 with this evidence. Claim number 1, the offspring have mutations that affect their traits. I don't know that we have enough evidence at this point to refute that, but at this point, we definitely have enough evidence to support claim 3. So that's really where we are headed at the moment. Okay, so for homework, for this activity, you will revisit the anticipation guide, read an article about how sea anemones reproduce. Let's take a look at it in Amplify. We got 2 buttons. Yes, we do. First, revisiting the anticipation guide. We've done this many times before. It says, review your original response to this statement from the anticipation guide. An offspring cannot have a trait if neither of its parents have it. Well, what do you think? Do you agree with that? Disagree with that? What about the evidence? Always go to the evidence. And then, of course, you're going to read about sea anemones' 2 ways to reproduce. Oh, well, that's got to be handy. Let's read this really quick. You've learned a lot about gene inheritance through sexual reproduction. But what about asexual reproduction? Oh yeah, I've mentioned that, haven't I? Open Sea Anemones, 2 Ways to Reproduce article in the Amplify library. Read the article and answer the questions below, then press hand in to submit your article. Add annotations, please. But even more importantly, please answer these questions, okay? On the right over here. There's only 3. And then make sure you hit hand in. And after that, hey, you are done Whew, this was a lot of stuff. This was good though. This was good application of what we're learning, and I'm excited to hear what you took away from it. So we'll see you next time.